If you are a human and are alive, you probably hate fractions. If you're dead, you probably don't have any strong feelings about fractions, as the dead often choose to remain impartial on a variety of different subjects. But fear no longer, because we are going to take some actions so you too can like fractions. It's a nice rhyme. This video is going to start from the very emptiness of no fraction knowledge at all the way up to where early 90s educational videos might say something like, "Well done, you've joined the fraction faction, that makes you cool in the 90s. But it doesn't make you cool in the 90s, or ever. If anything, it'll make you better at fractions, but maybe not." Starting from no fraction knowledge at all, we're looking at something like 8/10, the mere sight of which should send you into a frenzy where you leap from your desk and start a small fire in the corner of the room. Alternatively though, if we look at the numbers 8 and 10, we can see that both have a common factor in 2. Both can be cancelled by such to make 4/5. Similarly, with fractions like 3/9, we can see that both can be divided by 3 to make a third, and 27/54 can just be cancelled down to make a half. Fractions are often best cancelled down as soon as possible, as they are often much easier to work with. Also useful to know, if you cancel down something to having just a 1 as the denominator, then that just means the numerator. This is because anything divided by 1 is equal to itself. 4 divided by 1 is 4, 9 3/4 divided by 1 is the same, and a romantic meal divided by 1 is a very sad Valentine's Day indeed. The next small step up would be conversion between mixed numbers and improper fractions. You commonly want to express your answer as a mixed number, but although they are nice to look at, they can be extremely annoying. No particular group of people spring to mind. A common relatable fraction anecdote would be something like cake or pizza, as these are really the only sliceable foods. But to differentiate this video among the others, we're going to use something different, and that is going to be a very circular shape, like a circle. What we need to remember about improper fractions is that the top number represents how many slices we have, and the bottom number is how many of these slices are necessary to make one whole. For example, if we have 67/9, we can see that 9 goes into 67 7 full times, as 9 times 7 is 63. This leaves a remainder of 4/9, meaning as a mixed number we have 7 full circles and 4/9 of 1. If we look the other way round, no, as in converting a mixed number like 4/7 to an improper fraction, as this would be much easier to multiply and divide, we can see that 4 wholes means 4 times 7/7, which equals 28/7. Add this to the other a 7th, and this gives us a final answer of 29/7. Now, here's the point where you're going to want to get ready, because we're going to move on to multiplying fractions, and this is where things get actually much easier. This is really easy, but exam boards like to pretend it's hard, and I think we should play along with that, because as long as we do, they'll continue to give it lots of marks on exam papers. Multiplying is incredibly easy, as if we have a question such as 2/7 times 3/4, we're going to pretend it's not a fraction question at all. We're going to do 2 times 3, and then we're going to do 7 times 4, resulting in 6 and 28. We're going to then just remember it's a fraction question and draw a little line there. Once we cancel this down, as we should always do, we get a final answer of 3/14. If we have a slightly more difficult question, like 1 3/7 times 2 and a 19th, we are going to first convert these to improper fractions. This gives us 10/7 times 39/19, resulting in 390/143. Whilst ugly at first, this can be easily cancelled down to 30/11. If the answer is required as a mixed number, you can then make this 2 and 8/11. Little side note, if you want to appear extra not inept, if we have a question like 3/2 times 2/5, we can see that this would be the same as 3 times 2 over 2 times 5, meaning we can cancel the 2's to arrive at a final answer very quickly of 3/5. Nice. Dividing fractions is where we get a whole 1 extra step. If we have something like 2/5 divided by 3/4, all we're going to do is flip the second fraction to get 4/3, and then times 2/5 times 4/3 to get 8/15. Adding fractions is probably the first fractions chapter where you can be especially prone to mistakes. What a lot of people do is when faced, for example, with 2/3 plus 3/4, they'll simply add the top, add the bottom, and arrive at a lovely answer 5/7, which is incredibly incorrect. If you have done this before, that's fine, except I do in fact hate you passionately. It makes no sense to add the top and the bottom, as 2/3 plus 3/4 means 2 times a third plus 3 times a quarter. It's like adding 2 50p coins and 3 20p coins to arrive at an answer of 5 70p coins. What are you doing? Just no, just stop. Give up maths. Don't give up maths. Instead, what we're going to do is make sure the denominators are the same, and then we can add the numerators. This means that once we convert the numerators as well, both fractions are talking about slices of the same size. This means if we have, for example, 2/3 of a pie plus 4/3 of a pie, together that is 6/3 of a pie. 2 pies if you are vaguely sane. With 2/3 and 3/4 though, we need to find any number, preferably the smallest, that 4 and 3 both go into. This happens to be 12. So we times 2 and 3 by 4 so that the denominator becomes 12 and the numerator becomes 8. We then times 3 and 4 by 3 so the denominator also becomes 12 here and the numerator becomes 9. This becomes a simple addition of 8/12 plus 9/12 to arrive at 17/12. We never add the denominator when adding fractions, as 3/4 plus 2/4 clearly equals 5/4. By that logic, this would equal 5/8, and that does not make sense at all. Subtraction is done in a very similar way, where we make the denominators of the two fractions the same. For example, with 3/2 minus 4/7, we want both of the denominators to be the lowest common multiple of 2 and 7. We can see that the lowest number that both of these numbers go into is 14, so that is going to be the denominator. To do this, we times both the 3 and the 2 by 7 to get 21/14, and the top and bottom of 4/7 by 2 to get 8/14. This then gives you the answer of 13/14. This can't be cancelled down anymore, so it is already in its simplest form. Converting two fractions to have the same denominator is not only used in addition and subtraction, but also when ordering. If we have 5/7 and 6/9, it is quite hard to see which one's bigger. Therefore, what we're going to do is convert both to have the same denominator being 63, as this is the lowest common multiple of 7 and 9. To do this, we times the 5 and the 7 by 9 to get 45/63, and the 6 and the 9 by 7 to get 42/63. This makes it very clear that 5/7 was bigger all along. The final and most anticlimactic part of fractions up to GCSE is fractions of amounts. For example, Timmy is a young boy. There are 240 insects in Timmy's garden. If Timmy eats 1/6 of the insects in his garden, how many insects does he eat? This is a very simple question, and all we do for this is essentially times 240 by 1/6. This is the same as dividing 240 by 6. This gives you an answer of 40. This question could get a little harder though, by saying something like, if Nancy then eats 3/4 of the remaining insects, how many does she eat? To do this, first we find how many insects are left after Timmy's ravaged through the garden, by doing 240 minus 40, leaving us with 200. We then find 3/4 of 200. It should be fairly simple to see that 1/4 of 200 is 50, and times this by 3 to get a final answer of 150. Hopefully this video has provided some context or just insect anecdotes about fractions, and this is the end of it now.